Yes, you heard it right. So let's say if I have to go back in my past and if I have to restart my AI journey, right? If I have to again relearn machine learning, right? Probably I'm gonna skip LSTM, RNNs, GRN, these kind of thing, right? If you are thinking about to work into NLP field, right? I'm not talking about computer vision. Uh, that will I will also talk, but in the later, right? In the end, probably I'll touch upon that as well. So why I'm saying that, as we know that, probably even might not be knowing, but I've been working for the LP engineer for 2 3 years back in 2018-19, right? And I have some teaching experience in deep learning, machine learning, right? Currently, I'm a quantum engineer where I develop quantum algorithms. Now looking back, if I have to relearn, right, machine learning, I would probably skip RNN, LSTM, or GRU, right? Because these are like I would say depreciated algorithm. They don't perform really well for long text and everything. And whereas attention kind of work for everything good, right? So all the chat GPTs and everything, right? These big transformers you heard about is probably attention based model, right? So if I have to restart my journey, how I would basically it will be something like I'll start with calculus, try to understand slopes and these all things, then learn optimization. Once I learn optimization, I will learn linear regression, logistic regression. Then I'll try to understand how same kind of classification regression tasks done for multiple labels, right? For multi-class. That once I understand that, probably I'll go and learn neural networks, right? And I'll skip SVM on purpose. I'm telling, and I'll skip naive based decision tree, these kind of other models as well. Uh, Reinforcement learning I'll also skip for now, and like PCM, SVD, and this kind of thing. That's how these things are really handy, but somehow I will skip. So basically, neural network. Then I understand neural network, and directly from neural network I will probably if I wanted to go toward NLP field, right, then I will learn attention after neural network, and or if I have to go toward computer vision side, I will probably understand convolutional neural network, right? Here the two trees are branching, right? And even though once in computer vision, once I learn connects, right, then there is something called recurrent units or something like that, which basically passes on uh, information from one layer to another layer, right? So there are lot of recurrent neural networks or something like this. This is different from RNNs. What I'm saying is basically passing on the information from a lower level to upper layer so that they don't forget the information about the previous information, right? So this I'll touch upon a little bit of that. And so if you're in computer vision, you need to have understand attention, because all the futuristic models will be attention based, and then convolution neural network. So both, if you understand, you're good for computer vision. And then on the other hand side, in NLP, I will, after immediately learning neural network, I will go for attention, and understand attention, how it works, understand it back propagation as well. Neural network, you need to do back propagation as well, right? So you can understand it in a very deep way. And then after that I will learn transformers, right? And once those things are done, probably then I will suggest go for reinforcement learning, right? So that you can understand how actually ChatGPT was trained, right? Some part of reinforcement learning was used over there. So you understand reinforcement learning, that is really cool and everything, right? Uh, you understand it, but then once this I've reached this stage, right? Then I will probably like to come back and understand. You can then explore the other SVM as well, right? That's more like optimization or something. If you really go on to deep in optimization, then you can explore how PCA works and these other things, right? But if you follow this neural network route, you can easily understand this how big large language models work. And in computer vision side, probably CNNs, then probably go for attention. That would be more than enough for you guys to understand. And then there are Siamese network where you can do comparisons and everything. So there will be small models which are like small, not models but tweaks that helps your model that he has to learn on the way. Then you can learn about GANs as well, generative adversarial network models, right? So this is the pathway I'm going to take. Which this kind of information I didn't had early, so I kind of deviated in a lot of different areas, which kind of gave me a lot of knowledge breadth wise, but depth wise, if I have to go, this is the path which I've described. I will take, and that will basically will make you job ready and everything, right? So that is the thing which I wanted to correct if I was you, early student in data science or something like this. When these things happen, then you can focus on like basically start working, and then you will basically as whatever the needs are. Then you have cosine similarities and everything. How you can find embeddings, you can learn about embeddings and all. uh, what else? A lot of there's some clustering algorithms, right? That is based on optimization. So what I'm saying that when you learn calculus, then you understand maximum minima, this kind of optimization stuff. So this optimization, all like our whole machine learning is kind of optimization. If you think in a way, right? If you understand optimization, you're gonna have so much application in field of AI, machine learning, even quantum computing and other field, right? Differential equations and everything, right? You're gonna be really helpful in those kind of things. So understand optimization. Once you understand, you will able to understand neural network really well. Linear regression, logistic regression, you will very understand really well. Then you can understand clustering algorithms, right? Which I've been talking to avoid, which you can again start back. And what else? Then you can probably, if you have so much time, and then you can go and understand decision tree, naive Bayes and everything. This will be probably in your syllabus, but they have, but most of the time, neural network will tend to beat these kind of algorithm in different scenarios, right? SVM kind of is winner, but it's also basically it is a like updated version of linear regression or logistic regression, right? Which is another application of good optimization algorithm. How you can use optimization in a better way to come up with algorithm like SVM. So hope this kind of helps to improve your learning. I hope you have subscribed. So much more this kind of videos will be coming, and also a in-depth course I will be releasing on AI, and then later on quantum computing. So I hope you are subscribed. So much like this is material I will be releasing for free, right? If I tell you I was associated with a learning platform. If you hear about, it's called Hero Wired, right? And then there was a Board Infinity, right? So I was a teacher over there, and literally I used to get paid for this kind of thing, do this kind of counseling or teach, right? If I tell you my rates, you will be like I used to get like 4K, 4K per hour, like per hour if I teach one for 1 hour, 4,000 rupees, right? That was a huge money back then in 2022, right? So this I hope you are subscribed. I maybe I'm self boasting too much now. So okay, let's see you in the next one.